So, picture this. Your application is humming along, processing thousands of critical transactions every single minute. It is literally the lifeblood of your business. But then, what happens when a key partner, a service you absolutely depend on, just goes dark? And I don't mean for an hour, I mean for weeks. Well, today we're going to dive into the silent danger of permanent data loss in modern systems and the simple, kind of elegant backup plan that can save your bacon, the dead letter queue.
Let's jump right into a real-world scenario. Meet Timothy. He's a junior software engineer, and he gets this urgent memo about a vendor that makes his heart sink. He walks over to his senior colleague and drops a bombshell, the 5 words that no tech team ever wants to hear. We have a massive integration problem.
And here's the crisis in a nutshell. Their external payment platform, it's going offline for 16 full days. 16 days! But here's the kicker. Their own system, the one sending billing events to that platform, it only retries for 24 hours. So what happens to all that critical billing data for the other 15 days after that first day is up?
This, right here, gets to the absolute heart of the problem with these modern asynchronous systems. Where different parts of an application talk to each other in the background. Where does that data actually go when something breaks? This isn't like a web page that fails to load where you get an instant error message. Nope. This is something way, way sneakier.
Let's just trace the journey of one of these failed events, shall we? Okay, step 1. The billing service sends out a payment processed event. Simple enough. Step 2, it immediately hits a brick wall because the target platform is totally offline. Step 3, the system, bless its heart, tries again and again and again, but after 24 hours, it just gives up. And here's the terrifying part. Step 4, that event, that critical piece of data, poof, it is permanently lost. It just vanishes into the ether.
The senior engineer in our story, Margaret, she calls this the silent danger. And it's the perfect name for it. See, unlike a direct API call that fails loudly and right away, these background events just disappear without a sound. You might not even know you're bleeding data until weeks later, when you get some very awkward questions from your finance department. Okay, so how do we prevent this silent catastrophe? How do we stop this from happening? Well, you build a safety net. And in the world of AWS, that safety net is called the dead letter queue, or DLQ for short.
So what in the world is a DLQ? Honestly, the best way to think of it is just as a holding tank. It's a special queue, and its one and only job is to catch and safely store any messages or events that have failed all of their processing attempts. So instead of just vanishing, they get routed to this safe harbor for later. They're not lost, just waiting.
So how does this actually make your system stronger? Well, first, and this is the big one for Timothy's problem, it catches events after all the retries are exhausted. Boom, no more permanent data loss. It also isolates those weird malformed messages. Some people call them poison pills that could otherwise gum up the works. And finally, it gives you visibility. You can set an alert to know the instant things are failing, not days later.
This is fantastic, right? The data is now safe. It's all sitting there in the DLQ. But this brings up the next obvious question. And Timothy just nails it. On May 18th, when the outage is finally over, what do we do? I mean, how do we get those thousands of saved messages out of the queue and back into the system where they belong?
Back in the day, the answer to that was painful. You'd have to write a custom script to pull every single message and resubmit it. It was tedious and error-prone, but not anymore. Now, there's a feature that honestly feels a little bit like magic, the SQS DLQ Redrive.
The definition really says it all. It's a native, built-in AWS feature designed to solve this exact problem. Its sole purpose in life is to take all the messages that have piled up in the DLQ and send them right back to their original target for another shot at processing now that everything is healthy again.
And here is the most powerful part. With the click of a button, that's it. What used to be a full day of careful, stressful scripting is now a single action in the AWS console. This one click automatically manages the entire reprocessing of that 16-day backlog. I mean, talk about an operational game changer. It's incredible. So let's just step back for a second and look at the bigger picture here. What has really changed? Because the system hasn't just been patched, it's gone through a fundamental transformation. It's gone from being fragile to being truly resilient. And, I mean, the contrast is stark. It's night and day. Before, you had a black box system where failures were invisible, which led to that silent, permanent data loss. The system was fundamentally fragile. But after implementing a DLQ, you have full visibility. You have a safety net for all your data. The system is now resilient by design, built to withstand these kinds of real-world problems.
So, the big takeaway is this. Event-driven architecture is incredibly powerful, but it comes with these hidden risks. The good news is the solution is straightforward, it's elegant, and it's built right into the platform. And that just leaves us with one final question for you to think about. Your architecture runs on events. Where's your safety net?